Sixth grade, Module 4, Lesson 8, Classwork, replacing numbers with letters. Opening exercise. So we have 4 plus 0 equals 4. That's true. Well, the first question says how many of these statements are true. So let's just go through them and see if they're true. So 4 plus 0, that is true. 4 times 1 is 4. 4 divided by 1 is 4. 4 times 0 is 0, and 1 divided by 4 is 1/4. Remember that a division problem is just a fraction, so that is true. So how many of these statements are true? Well, all of them. How many of those statements would be true if the number 4 was replaced with the number 7 in each of the number sentences? So it's saying that instead of 4, everywhere you see a 4, it turns into a 7. So let's see. We did 7 plus 0, we should get 7. 7 times 1 equals 7. 7 divided by 1 equals 7. 7 times 0 equals 0. And 1 divided by 7 equals 1/7. So those are all true. So we can say, again, all of them would be true. Would the number sentence be true if we were to replace the number 4 with any other number? So saying we replace 4 with anything, whether it be a negative number, a positive number, 0, anything. Well, let's try. So we already tried 7. I'm sure it would work if I had 8 or 9 or 10 or any other positive number. Let's try a negative number and see if it would work. Let's try -7. So -7 plus 0 would be equal to -7. -7 times 1 would be equal to -7. -7 divided by 1 would be equal to -7. -7 times 0 would be equal to 0. And 1 divided by -7 would be equal to -1/7. So that checks out. What about 0? Let's try, I'll do a different color. 0 plus 0 equals 0, so that checks. 0 times 1 equals 0. 0 divided by 1 is 0, because if you have a 0 and you just split it up, you get nothing in each group. 0 times 0 equals 0. So all of these have checked out, and then 1 divided by 0 equals, so if you put in 1 divided by 0 in your calculator, you'll probably get an error message. And that's because if you have 1, you can't divide something into 0 groups. Like, for example, if I said, if you had 5 Skittles and I told you to divide them into 0 groups, you'd be like, what? That doesn't even make sense, right? So this one does not work because it's not possible. You can't do that. So would the number sentence be true if it were to replace any number with 4 with any other number? So that would be a no. We can say no, the first 4 are true, are always true. But you can't divide by 0. What if we replace the number 4 with the number 0? Would each of the sentences be true? So that's kind of what we just talked about, right? The first 4 would be true, but not the last one, for reasons that we just discussed. What if we replace the number 4 with a letter G? Write all 4 expressions below, replacing each 4 with a G. Okay, so we're replacing 4 with a G. So G plus 0 equals G. G plus 1, or G times 1 equals G. g times 0 equals 0. And well, I mixed up that order, but that's okay. G divided by 1 equals g. And 1 divided by g equals 1 over g. Are all these true except for g equals 0 when dividing? So will these all be true as long as g is not equal to 0? Yes. Example 1, additive identity property of 0. G plus 0 equals g. Remember, a letter in the mathematical expression represents a number. Can we replace g with any number? So can we replace g, let's say 6, and it'll always be true. So 6 plus 0 equals 6. Let's try 0, because usually 0 is the exception. 0 plus 0 equals 0. So if g is 0, that works. And then let's try negative number. Negative 2 plus 0 equals negative 2. So I would say yes. Choose a value for g and replace g with that number in the equation. What do you observe? So we already kind of did that. We notice that the value doesn't change. So the value of g stays the same. When 0 is added. Whoops. Misspelling a lot today. When 0 is added to g. Repeat this process several times, each time using a different number for g. So we're just going to do some examples. So let's try, I kind of already did it. Oh well. Okay, 7 plus 0 should equal 7. If g was equal to 7. If g is equal to 4, it would be 4 plus 0 equals 4. If g is equal to 0, 0 plus 0 equals 0. If g is equal to negative 1, negative 1 plus 0 is equal to negative 1. So there's just some examples. Will all values of g result in a true number sentence? So the answer is yes. No matter if we had a positive, negative, or 0, number sentence is always true. Write the mathematical language for this property below. So g plus 0 is equal to g, and this is explaining or showcasing the additive identity property of 0. It's a mouthful. Additive identity property of 0. Really fancy way of just saying any number, again, misspelling the word, any number plus 0 equals itself. Example 2, multiplicative identity property of 1. So this time, g times 1 equals g. We want to know if that is always true. Remember, a letter in a mathematical expression represents a number. Can we replace g with any number? So I'm going to come back to that one because last time I answered all the other questions and then within that answer. So let's skip to the number next one because we're going to experiment with it. So choose a value for g and replace g with that number in the equation. What do you observe? So we're just going to say g equals, I'm picking 3. So if g is 3, 3 times 1 equals 3. And with g being 3, that is true. So let's choose 0. So if g is equal to 0, is 0 times 1 equal to 0? Yes, that works. And let's choose a negative number. Negative 4. Negative 4 times 1 equals negative 4. So that works. So I'm going to go back to the first one. Can we replace G with any number? And I'm going to go with yes. Will all values of G result in a true number sentence? Experiment with different values before making your claim. So we already experimented with different values. So I'm going to say that the value of G doesn't change when it's multiplied by 1. And write the mathematical language for this property below. So we're going to give it another fancy name. And when we do G times 1 equals G, that is demonstrating the multiplicative identity property of 1. Which basically just says any number multiplied by 1 is equal to itself. Example 3, commutative property of addition and multiplication. We have 3 plus 4 equals 4 plus 3, and 3 times 4 equals 4 times 3. Replace the 3's in these number sentences with the letter A. So anywhere there's a 3, we're going to put A instead. So we would have 3, but it's A plus 4 equals 4 plus A. And then we'd have A times 4 equals 4 times A. So notice they've just switched places. So choose a value for A and replace that A with that number in each of the equations. What do you observe? So if we have 5 plus 4, does that equal 4 plus 5? So this time I'm choosing A to equal 5. So this would be 9 and 9. So those are equal. If we do 5 times 4, it equals 4 times 5. Is that true? So that's 20 and that's 20. So those are also equal. So we could say that they are equal, or the number sentences are true. Or you could say the equations are true. Will all values of A result in a true number sentence? Experiment with different values before making your claim. So we already tried a positive number. Let's try 0. So if we had 0 plus 4, would that equal 4 plus 0? Yes, because 4 is equal to 4. If we had 0 times 4, would that equal 4 times 0? And that would be yes, 0 is equal to 0. So it works with 0. Would it work with a negative number? Let's try negative 1 plus 4 be equal to 4 plus negative 1. So negative 1 plus 4 would be 3. And 4 plus negative 1, it's the same thing as saying 4 minus 1, would also be equal to 3. If we did negative 1 times 4, would that be equal to 4 times negative 1? Well, that would be negative 4 and negative 4. So those are also equal. So yes, I think any number. Yes, any number, including 0, can be used in place of A. Now write the equations again, this time replacing the number 4 with a variable B. So this time we're not even going to use 4, we're just going to use B. So A plus B equals B plus A. and A times B equals B times A. So will all values of A and B result in a true number sentence for the first two equations? Experiment with different values before making your claim. So let's make A equal to 2 and B equal to 3 and see if it works. So if A is equal to 2, we'd have 2 plus 3 equals 3 plus 2. So 5 is equal to 5, that's true. 2 times 3 is equal to 3 times 2. So 6 is equal to 6, so that works. Let's try one of them being 0. Let's try A is equal to 0 and B is equal to 5. So 0 times 5 is equal to 5 times 0. So 0 is equal to 0. 0 plus 5 would be equal to 5 plus 0, and 5 is equal to 5, so that works too. And let's throw in a negative number, like negative 3 is equal to A, and B is equal to, let's just keep it simple, 2. So negative 3 plus 2 will be equal to 2 plus negative 3. So negative 3 plus 2 would be negative 1, and 2 plus negative 3 was the same as 2 minus 3 is also negative 1, so that works. And then negative 3 times 2 would be negative 6 is equal to 2 times negative 3, also negative 6. So that works. So yes, I would say all values would work. Write the mathematical language for this property below. So A plus B equals B plus A. That is the commutative, meaning that they can move spaces. It doesn't matter which order they're in. When you add them, you get the same answer. So commutative, and since we're adding, it's the commutative property of addition. Order doesn't matter when adding. And then we have A times B equals B times A. So same thing. This is, except it's multiplication. So this is the commutative property of multiplication. So order doesn't matter when multiplying. And in example 4, we have 3 plus 3 plus 3 plus 3 equals 4 times 3. So the 4 representing the 4 groups of 3, 4 times 3. And 3 divided by 4 equals 3 over 4, 3/4. Replace the 3's in these number sentences with the letter A. Okay, so we'd have A plus A plus A plus A is equal to 4 times A. And then we're replacing 4 with A. So 3 divided by A. Oh wait, we're replacing the 3's. So actually, A divided by 4 equals A over 4. Choose a value for A and replace A with that number in each of the equations. What do you observe? So let's make A equal to 5. So if we have 5 plus 5 plus 5 plus 5, is that equal to 4 times 5? Well, 5 plus 5 plus 5 plus 5 is 20, and 4 times 5 is 20, so that works. And if we did 5 divided by 4, we would get 5/4. So that also works. So I would say that, what do you observe? I observe they are true number sentences. Will all values of A result in a true number sentence? Experiment with different values before making your claim. So I'm going to do the same thing I did last time. I already used positive values, so now I'm going to use 0 and choose a negative number. So let's do 0. If A is equal to 0, we would have 0 plus 0 plus 0 plus 0 would be equal to 4 times 0. Yep, that works. And if I had 0 divided by 4, is that 0 fourths? Well, if I start with 0, then, and divide it into 4, I didn't have anything to start with, so I'm going to end up with 0. So that also works. Now let's try a negative number, maybe negative 2. So if I have negative 2 plus negative 2 plus negative 2 plus negative 2, is that going to equal to 4 times negative 2? So this would be negative 8, and 4 times negative 2 would also be negative 8, so that works. So then if we have negative 2 divided by 4, that would be negative 2 fourths. So I would say that, yes, any number including 0 can be used in place of A. Now write the equations again, this time replacing the number 4 with a variable b. So instead of using 4, we're going to use b. So we would have a plus a plus a plus a equals b times a. And a divided by b equals a over b. Will all values of a and b result in a true number sentence for the equations? Experiment with different values before making your claim. Okay, so first thing that jumped out at me, and it jumped out when I was writing it, is there are only 4 a's, so this number would have to be 4. Like if there were 5 a's, then it would be 5. If there were 6 a's, it would be 6. But the way that it's written, that number must be 4. So I'm just going to go ahead and say that a plus a plus a plus a plus, or equals 4 times a. We can say that any value can be substituted for a. But only 4 can be used. So this was B. For B, because there are exactly 4 a's in the equation. And let's try for a divided by b equals a over b. So if we wanted to make b, let's see, we already know that it'll work for any value of a. So let's make a equal to 3 and b equal to 2. We already know that it works for positive numbers, so never mind. Let's make b equal to 0. Okay, so 3 divided by 0 equals 3 over 0. So this is something we talked about earlier. We can't divide by 0 because if you put it in 0 groups, then it's not going to work. So this doesn't work for 0. So let's say it doesn't work if b is 0. But will it work if it's negative? Let's try a equals 3 again and b equals negative 2. 3 divided by negative 2 would just be 3 over negative 2, negative 3 halves. So that does work. So it'll work for positive, negative. It just doesn't work if b is 0. And that is the end.